let's take a quick look at the Formlabs Fuse specifically. And because this is about making the most of the Fuse, we'll talk about the whole supporting ecosystem as well, because these additional machines are really the first step to making the most of the Fuse, because they significantly reduce the amount of operator time and time that you're going to be spending getting the parts out of the powder and mixing the powder and all that type of thing. And I won't do a full breakdown because we've already got a couple of videos over that, but I do think it's important to discuss the machines and how they work, because it'll also help us later on in our discussions in this webinar. So starting with the Fuse and some of the highlights here, it's one of the most affordable and capable SLS printers to date, and it has everything from built-in AI for print quality tracking and cloud connectivity for remote printing and monitoring, and even a built-in maintenance tracker. So this thing is really built for serviceability, and it's meant to be a workhorse and just run nonstop. So it's awesome to see these things, especially a bunch of them lined up next to each other. And one of the other cool things about the Fuse is that it's one of the first SLS printers that doesn't need an inert environment to print. And you can hook it up to nitrogen, and that may give you some benefits with certain types of materials and better refresh rates, but typically you're just going to run this thing in ambient air. So obviously there's a ton of stuff to talk about here with the Fuse, but one of the best things about it is actually on the inside, and it has to do with this build chamber. So in most SLS printers, the temperature on the inside of the chamber during printing is absolutely critical, and that's the same for the Fuse. The plastic powder is heated to just below the melting temperature, and the laser is used to selectively sinter or melt the powder together and create a part. So if there's any variability in the temperature of the powder, it may not melt thoroughly, or it may melt too much, and your parts could warp and start to have surface defects. So it's really important to keep that stability during printing, but it's also important during cooling, because if you were to just extract your part right away, the same thing's going to happen. You're going to have different warpages and curling, and your parts might even crack. So the surrounding powder is really important, even during cooling, because it keeps the part into shape and it also sort of insulates it, which is great, except for most SLS printers, you recapture your powder within the same device that you print with. And so the printer is down and unproductive during the entire cooling process, and that can take up to 14 hours in the Fuse. So Formlabs actually decided to separate the powder reclamation from the printer, and that's how we take advantage of this removable build chamber. So we can actually pull this build chamber out once we're finished printing, and we can set it aside to cool in the Sift, and then we can add a new build chamber right away into the Fuse and kick off the next print. So that's step one of making the most of the Fuse, is to have a couple of build chambers that you can rotate between, and try to set up your schedule where you can rotate these during the workday. You don't have to go up there in the middle of the night or something crazy. And that way you're maximizing your productivity, minimizing the downtime for the printer. So that leads us into the Sift, which is where your chamber will end up once it's cooling, or even during cooling. You actually use this same plug and you plug it into the Sift, and there's multiple temperature sensors inside of the build chamber. And so the Sift is able to track the temperature and let you know when it's safe to remove parts. And when it is, the build plate rises up and you move this whole chunk of powder and parts over, and any of the unused powder falls down through a mesh filter into a hopper. You separate your parts out, and then there is another hopper on the other side for new powder, because the powder does degrade a little bit each time it goes through this heating and cooling cycle. And so you want to mix a little bit of new powder with the used, and the Sift controls that. It's called the refresh rate. It's the rate of new powder to use, and we'll talk a little bit more about that later, but for now just know that it's able to have those two places to put the powder, and the Sift knows how much of each is in there, and it'll kind of give you warnings and help you set your refresh rates. So moving on to the last piece of the system, the blast is something that I didn't really know we needed until I started working with SLS. And it's necessary because unless you spend a ton of time in the Sift, you're not going to get every single little bit of powder here, or you're going to spend a really long time trying to get every nook and cranny. So a blasting cabinet is important to be able to blast off just that light layer of powder that might be left on your parts. And that's actually one of the biggest pieces of advice I have, in the beginning, I spent so much time trying to get every nook and cranny brushed off and clean to try and save that powder. But realistically, the amount that you're saving and reclaiming isn't that much. And the amount of labor that you spend trying to get those parts super clean is worth quite a bit more than that in most cases. So Formlabs' own recommendation is to get parts looking roughly like a potato, where you can sort of start to make out the part, but save the nooks and crannies for the blast. And initially we didn't have the blast from Formlabs because it didn't exist yet. And I found out how difficult it is to hit a part from every single angle to make sure it's fully clean. And not only that, but you're picking up each individual part and rotating it one at a time. So it takes quite a while to get these things blasted off, but the blast solves all that because it has this rotating drum with automated blasting cycles. So you spend just a few minutes in the Sift now, and then you bring it over to the blast, you put your parts inside, and then you just walk away. It's got its automated cycle that it'll run through. And then the second great thing about the blast is it eliminates a whole other step, which is before we had the blast, we had to clean the parts off even after they were blasted because they're covered in blasting media. But the blast has a deionizer built in, and that just keeps the blasting media and the powder from sticking to the part. So they are white glove clean, ready to go right out of this machine. So it's also got a polishing option coming in the future, and that's really exciting because we're getting injection molded looking parts right out of this machine that don't even look 3D printed. So awesome to see that, and we're looking forward to it.